We're now going to look into violation of the sure thing principle, so that's particular violations of the expected utility model, and we will see that they give really convenient ways for finding out about the nature of rank dependence. For instance, if a person is optimist or pessimist or something else. The reasoning that we're going to do in a moment will be quite similar in spirit to first reasoning that we did about the LA paradox. Again, I'm going to ask you, don't use paper pencil, only think, only your mind's eye, and only use qualitative argument, like if this goes this way, then that goes more that way. No calculations. So try to reason in that manner. We did it before, we'll do it again. With that understood, let me bring up the first figure of my reasoning. I will call it the reference case. There's a left and a right prospect. Probability is P1, P2, and Q. Q is 1 minus P1 minus P2, but this turns out to be convenient notation for us. Same probability for the right prospect, and sure thing principle has common outcomes. So no surprise, here are common outcomes in the middle branch. They will be used for manipulation in the sure thing principle. Other outcomes, alpha, beta, gamma, and delta. And the ordering of the outcomes, delta is best, alpha is worst. I have all kind of habits in my life that made life a bit easier. Whenever I can, if I have to work with two outcomes, I use gamma beta, and I think gamma is good, beta is bad. If more outcomes, then I think, well, delta means delicious, and alpha means awful. So with that convention, that makes memory life easier to remember things. So such small habits, maybe you can also have them make your life easier. Anyway, I followed the habit here again. You see, I'm using colors, and always green color indicates the direction you want to go. Well, if you see the upper branch, then delta is bigger than gamma. The upper branch is a reason to make you want to go left. The lower branch, beta is bigger than alpha, is a reason for going right. So that's why I use the notation. And this reference case, the common outcome is in the middle between the others. It is smaller than gamma and delta. It is bigger than alpha and beta. So it's really in between. Now I'm assuming in this reference case that we have indifference, so that the argument for going left and the argument for going right exactly offset each other. We have in the numbers could be chosen exactly to get that. We have indifference here. This is the reference case. Of course, sure thing principle, we're going to see what happens if we change a common outcome. So no surprise to you that in another situation, the left case, I'm going to change the common outcome. I'm going to replace it by a common outcome C plus that is quite bigger. It is bigger than all the others. So it's also bigger than the biggest of the others being delta. That's the situation here. I am following the convention of notation here that in each lottery I display it in such a way that the best outcome is in the upper branch, the highest branch, and the worst outcome is in the lowest branch. So that's a convention in this slide, not always, but only in this slide. So here when I say high, it means in the terms of the figure, so it will not be ambiguous. So here I'm allowed to say high for rank only on this slide. Okay, with that understood, now that the common outcome C plus is the best for all, it gets the highest position in the figure. There it is, probability Q, and the other outcomes with the other probabilities. So there we are. And now I'm going to ask you about to speculate about the preference. First, imagine that your decision maker is a pessimist. Then, what would the preference be? Now you can pause the video, see if you can reason by yourself what that would be. When you're done, come back. So I assume you're done. So then the answer will be, and I will do the reasoning for it, the answering will be that the preference will be for left. And the reasoning is as follows. First, let's look at the lowest branch in the two figures. Everything is the same there. Also, the rank is the same. So nothing really changes for the lowest branch. That doesn't give a reason to think that preference could change, that the violation of sure thing principle could come. Look at the middle branch here. It turned up here, but it gave a neutral argument. Well, the rank has changed, so the decision weight may have changed, but the neutral argument remains neutral. But that neither gives a reason to expect a change in preference or a violation of the sure thing principle. So let us then focus on the upper branch. Here it has the best rank. Here change, it has the middle rank. Now we assume we have a pessimist. That means that this person may pay more attention here to that than here. It's an argument for going left. So the argument for going left is receiving more attention, more decision weight. That means now the preference changes to a preference for left. That's why now we have this preference. Now you can try yourself to do a similar. Assume now that the decision maker is not a pessimist but an optimist. Then see if you can reason what the preference will be in figure in the left case. You can pause the video and after come back. Okay, I assume you're done. And of course, for the optimist, it's the other way around. It will be preference for right, because the optimist was, the only the lower, the upper branches of interest. Here it is best, and the optimist is paying much attention to it. Here it became middle, less attention, so less important. So here the argument for going left has been weakened, and that's why here we get a preference for going right. That's how it is with the optimist. Now, next question may take a bit more thinking. How would it be for inverse S-shaped people with such a probability weighting function? So these are likelihood insensitive people. And maybe you remember, if you see before you the shape of inverse S, and you see that for small probabilities, a small rank, that are good ranks, it is steep. And also for the high probability, the high rank, the bad ranks, that is, it's also steep there. But for the middle ranks, it is shallow. So this inverse S person is paying much attention, giving much decision weight to extreme outcome, both best and worst, and little weight to the middle outcomes. It's a sort of extremity orientedness. Now, with that refreshed in your memory, can you reason what the preference would be for inverse S? Stop the video and then come back. I assume you're done now, so then let me show you. For inverse S, the preference will be for the right. Because for inverse S, we only have to look at the upper branch, And the upper branch here is best ranked. It's extreme. You're receiving a lot of attention. Here it is middle ranked, not receiving much attention. Therefore, in the left case, the argument for going left has weakened, and therefore we get a preference for going right. So that's how it works for the inverse S shape. Now we go to another situation, the right case, and again we have these lotteries, but now the common outcome is changed into a very bad common outcome. It's worse than all the others. It's worse than the smallest of the others, than alpha. So now I depict the branch at the bottom, and here are the other outcomes. Then you can do similar reasoning. Question, what will happen, what will the preference be if your decision maker is a pessimist? So you pause the video and you do the reasoning. Okay, I assume you're done, and the answer is the preference will be for left. And reasoning, let me do it a bit slow again. If first we look at the upper branch, nothing has changed yet. The outcomes, the ranks are the same. So the upper branch does give a reason to expect preference to change or violation of the sure thing principle. I look at the middle branch here, it became the lowest branch here. It is a neutral argument. Well, it has changed rank, so the weight may have changed, but neutral remains neutral. So it neither gives a reason to think there would be change in preference or violation of sure thing principle. So the thing that we focus on now is the lowest branch here. It is the middle branch here. It has changed in the rank position from worst to middle. Well, that means the pessimist in the right case is paying less attention to it. So that means the argument for going right has become weaker. And that's why a pessimist will here have a preference for the left prospect. Next, now assume optimism, and maybe if you want to do the reasoning for yourself for optimism now, pause the video. Now here comes the answer. For optimist, there's a preference for going right. And the lowest branch has changed from low rank to middle rank, and optimist is paying more attention to it. Therefore, in this situation than in the reference case, therefore the argument for going right has increased, become stronger, and hence the preference for going right. Last question, you can pause the video again. How about inverse S? Now I give you the answer. For inverse S, the answer is that the preference is for left. And the reasoning is, well, it's getting a routine for you now, I hope. We see here the lowest branch is ranked lowest here, ranked middle here. So in the right case, the lowest branch is receiving less weight. That means the argument for going right has become weaker, and therefore there's a preference for the left prospect. So here you see that tests of the sure think principle could really easily give you a critical test to find out if people are pessimist or optimist, or maybe inverse S-shape, quite easily can be done. So this was qualitative reasoning. I'm going to stop the recording here. In next recording, there will be quantitative information for how to do calculations.